So when we look at it, the rules, everybody has their notes. We're going to do the first little section, 6.1. So start with greatest common factor and what does it mean. So it's just going to be of a monomial or one or two of them, and we want to find the greatest common number or the greatest number that goes into both of them. So here's your steps, what you need to do. Because you're going to have numbers and you're going to have variables. So for the numbers, find the largest number that goes into each one. So however many numbers you have, find the number that goes into all of them. For the variables, you list the variables they have in common and pick the smallest exponent. And then if you multiply steps 1 and 2 together, you get the greatest common factor. It's possible that there is not one, that the greatest common factor is 1. It happens. It's okay if it does. Okay, so let's just do an example of finding a greatest common factor. We want to find the greatest common factor between 45a cubed b and 30a squared. So just look at the numbers. What's the biggest number, that goes into 45 and 30? 15. Everybody agree 15 is the biggest number? What variable do they have in common? A, and the smallest exponent is squared. And you're done. Hard stuff today. Hardest part's finding the biggest number sometimes. Questions on that one? Okay, so then we might have to find the greatest common factor, and we're going to factor it out of a polynomial. So when we factor out the greatest common factor, first thing is be able to find the greatest common factor. And then we're going to rewrite it, so instead of just having one polynomial, it will look like this. We're going to factor the greatest common factor out front, and then whatever's left when we factor that out, our new polynomial will be in parentheses. Okay, so doing some examples. If we look at this one, 36x squared plus 42x. What's the biggest number that goes into 36 and 42? 6. Do they have any variables in common? An x. Just an x or an x squared? Just an x, right? Choose the smallest one. From here, a lot of you just simply know how to do this, but if you need some help on thinking how the numbers are coming, you just divide. What's 36 divided by 6? 6. I had x squared. I took 1 out, so there is 1 left. Plus, again, if you're not sure, 42 divided by 6 is 7. Does it have an x? Nope. And we're done. Okay, how about this one? 25x cubed y squared minus 35x to the 4th. Biggest number that goes into 25 and 35. 5. Here in 5. Do they have any variables in common? X to the 3rd, the biggest one, right? So we're going to factor that out. 25 divided by 5. 5, 2, 3. 5. I like 5. Here's just throwing out some answers, seeing if anybody else is going to know. 5. How about the x cubed? I had x cubed. I took it out, so it goes away, right? I'm left with y squared minus 35 divided by 5. 7. How many x's am I going to have left? 1 with 1 x left because I had 4 and I took 1 out. And we are done. How are we doing? Good so far? Yeah. All right, here's another one. More this time. We have 3 that we have to look at. What goes into -9, 15, and -18? 3. The difference here is this. If this first number is negative, we're going to factor out a -3. Only if the first one's negative. What about my variables? What variable do they have in common? X squared and 1y, right? All those variables, everything has an x and a y in it. So now -9 divided by -3 makes it +3, right? The x squared went away, the y went away, and I just have the z left. Minus 15 divided by -3, so 5. With just the x, the y and 2 of the x's are gone. And -18 divided by -3 makes it a +6. And what do I have left for variables? X squared y. Cruising. Everybody remember doing this? You guys have done so much factoring. We should be so good at it. So this one is similar. It's just that we're going to factor out a binomial instead of just like a number and a variable. So I still have two terms, and what do these two terms have in common?
B plus 5.
This time they have this b plus 5 in common. So that just means I'm going to bring out in parentheses that b plus 5. And then if I take that out, good luck. If I take the b plus 5 out of both of these, I'm left with a plus 8. And you're done.
Oh, I see. So you just take the front one, move it to the back.
Kind of, yeah.
What did you do?
I took out the b.
ones, the front, and you just like put them
B
together.
plus 5. Oh, yeah, I know what you mean.
So what do we do with the
It got rid of
Okay.
the thing in between.
I'm talking about
I don't know.
Yeah.
and we have on the next one.
They canceled that one to the.
Right, you're taking them out. If I take out b plus 5, it's gone. What's left? A. If I take out b plus 5, what's left? 8. So what's left?
A plus
Just
8.
factor. You got it. Okay, so let's look at this. I have 2 again. What do each one of these have in common?
X minus 5.
An x minus 5, right? So I'm going to take out that x minus 5. And then, so if I take the x minus 5 out, that means this goes away and I'm left with
Oh,
x plus 6. You don't need to put it in parentheses. We're going to do one big set. I still have this plus sign. If I take out this x minus 5, I have the 2x plus 5 left.
What's the point?
Yes.
You gotta combine.
So now in our second set of parentheses, you need to combine like terms. So my first x minus 5 will stay the same. It is 3x plus 11 when we combine all of our answers.
Great work, Chris.
Everybody's cruising.
Why is our class so smart?
I don't know, just you guys are just
Yeah, why is it always in this class smart?
because you've already done all this material for the last 2 years, you should be good at it. Okay, the last thing we're going to do is factor by grouping. When we factor by grouping, that means that we're going to have a 4-term polynomial. Okay, the ones we've looked at are 2 and 3. This time we're going to have 4. So you always want to start, if possible, factor out the GCF. If there is anything to factor out, do that first every single time. Okay? If there isn't one, that's fine. Don't worry about it. Then we're going to group together pairs of our terms. We have 4 of them, so we'll group them 2 and 2. Factor the GCF out of each pair, and then it's going to look like one of the 2 problems we just did right before this. Okay? There should be a common binomial. This says if there is, there should be, or you did something wrong. Okay? We'll factor it out like what we just did. Okay? If you don't have a common factor, then you might have to rearrange your terms, which we'll do an example and show you how to do that. So let's just look at some of these. So we have 4 terms. Do they have a GCF? Is there something that goes into 18, 15, 6, and 5?
No.
Nope. So we're just going to group them. I always start and just say, well, group the first 2 and group the last 2. It's okay. So what is now, just looking at our first group of parentheses right here, what's my GCF? 3A. So I take out a 3A. So then we'll take out the 3A. I'm left with 6 plus 5B, I heard. Plus, now is there anything in my second set that's in common?
Yes.
No. So if there's not anything, that means you just bring out a 1 and leave the parentheses alone. Not yet.
No.
So our goal when we just did what happened right here was to get what's in parentheses to be the same.
Oh, you do it and then you distribute it.
And then you factor that out like what we were just doing. So now they have the same thing. So now take out the 6 plus 5B. And if I take that out, what are we left with?
3A plus 1.
3A plus 1. That's why I always have you write this 1 out here, factoring it out, so you remember to put it in your final answer down here. Questions on that one? All right, here's another one. 21xy minus 28x plus 15y minus 20. Is there something that goes into all 4 of those numbers?
No.
Nope. So let's just start. Group the first 2. Group the last 2. So in my first set of parentheses, Here you guys ahead of me a little bit, 7x already. If I take out my 7x, I'm left with 3y minus 4. What are we going to take out of our second set? Just a 5. Because if the first number is negative, take out a negative. Otherwise, just positive. So if I take out a 5, I'm left with 3y minus 4. And again, that's what we want. We want these parentheses to be the same. If they're not, that's when we have to reevaluate what's going on. So now I take out that 3y minus 4. And what are we left with? 7x plus 5. You guys are cruising.
I think I've done this before.
I guarantee you have done this before. All right, here's another one. Does this one have a GCF? Something that goes into 24, 72, 9, and 27. 3. Do they have any variables in common? A p. So the first thing I need to do is factor out that 3p, which is our GCF. So if I factor out that 3p, I'm left with 8p cubed minus 24 p squared. Remember, just divide if you don't know. 72 divided by 3. Use your calculators. Plus 3, and I'm left with 1p and 1q minus 9q. Whoops, sorry. If you didn't take it out, oh, you mean like to do what we're going to do?
Like, after you divide everything by 3p, there's still a common variable of 3.
No,
You're tripping.
because 8.
You're gonna put 3 to 8.
Oh,
Gosh,
never mind.
He was just teasing, seeing if we were paying attention. So we're not done. Just because I factored out the GCF doesn't mean we're done with everything. We still have 4 right here, so now I have to do the same thing with our factoring by grouping and group the first 2 and group the last 2. Okay, so we can't just quit. I am for right now. I'm going to circle this 3p because we have to put it in our final answer, but I don't have to keep carrying it down because sometimes that gets confusing for you. So in my first group of green right here, what can I factor out?
8p2.
An 8p squared. And I'm left with
1.
just a p or 1p if you want to put 1p minus
3.
3. No p's, right? Plus, what am I going to factor out of my second one?
3.
A 3 and a
P. Q. No. Q.
q, which leaves me with a p.
It's crazy how it always is.
It is crazy how these always end up the same, aren't they? Yeah.
So why couldn't we just, like, in the beginning, just separate it into 2 things and divided it by 24p3 and then by 3pq, and then you would have gotten the same thing in a lot less steps?
You would have had to factor one more time at the end because the factors would have had something in common again. You can, and factor the GCF out again at the very end. Okay, so now I still have this p minus 3, right?
8p squared plus 3.
8p squared plus 3q is left, but we can't. Yeah, that's right. Drag down that 3p in front. Excellent. That's the one thing we forget sometimes is to bring down that GCF we took out at the beginning. You have to do that, yeah.
All of them?
Only if you take it out. So not all of them. All right, we have one more left. Is that right? All right, p squared, q squared minus 10 minus 2q squared plus 5p squared.
Bless you.
Bless you. Do they have a GCF? No. So if I look at this and I just start putting these together here, like, do the first 2 have anything in common? Do the second 2 have anything in common? And they're not the same, right? So that means that we're going to have to switch some things around. Okay? You can switch whatever you want. Just switch 2 to start with. So switch like the middle 2 or switch the last 2. Just kind of pick which ones you want to switch.
Switch
Okay. Switch the middle 2. All right, I'm going to just switch these middle 2 then. So p squared, q squared. Then I would have minus 2q squared minus 10 plus 5p squared. Because now I can do my parentheses, right? and they have something in common I can factor out. So what does my first group have in common? A q squared, which would leave me p squared minus 2. What am I going to take out of my second set? A 5, but because this 10 is negative, I'm going to take out a negative 5.
Why does it have to be negative?
Whenever the first term is negative, you always factor a negative out. And that gives me 2 plus,
Negative.
no, because I factored a negative out.
2 plus
Both.
plus negative 2.
But they're not the same now.
But I want to show you something because you're going to come across this. So when I do this, these are, what do you notice? They're not the same. Okay, you've already told me they're not the same, but what do you notice? What's different about them?
The
Plus and
opposite.
minus sign.
Okay, they're opposite, right? One's minus 2 and one's plus 2.
I know what you do.
You take rid of the negative.
Oh wait, no one caught my mistake on here. This should be a minus, whoops. This should be, I wrote it wrong. This should be 2 minus p squared. Okay? Because I took out a negative, so if I take the negative out, this becomes positive, this becomes negative.
So then it works.
Well, they're not exactly the same because this is p squared minus 2, this is 2 minus p squared, right? Just a minute and I'll answer your question. So to fix that, here's how you fix it, because you're going to have one of these on your homework. In our first one right here, just make this, I'm going to change my sign, my color, so you can see what I'm doing. Make this a negative, like factoring a negative out. When I add this negative here, it changes everything in parentheses, so it makes the p squared negative and the 2 positive. Yep.
Wow.
When I did that, now the parentheses are the same. They're in different order, but the p squareds are negative and the 2's are positive, right?
But why
Yeah.
don't you just take out positive 5 and then do the negative 2 plus b squared?
Because the majority, 99% of the time, that's not going to work for you
But it,
on this one, but that's it. So I don't recommend it, because if you don't factor that negative out most of the time, it won't work.
So you
No.
just change the ones right after the cube squared?
Just change the ones on the first one, yes. So now I have my, however you want to write it, 2 minus p squared or negative p squared plus 2. And then I have left negative q squared minus 5. The order you write these doesn't matter. If you switch these around, they're not, it wouldn't be wrong, as long as you have both sets of parentheses the same. Questions? Other questions on that one? Did I get them all answered? It's kind of one of our trickier ones. Okay.